Sketch the graph of y equals 3 divided by 5 times sine of pi x over 12 for x is an element of 0 to 24. Clearly label all axial intercepts, maximum and minimums with their coordinates. So because there's been no translations that have occurred, it means there's only dilations and possibly reflections. We can graph this circular function by just considering the period and amplitude of the graph. So first up, if we look at the amplitude, we're going to look at this value here, which is multiplying the circular function. So this 3 divided by 5 out the front. And this tells us that our amplitude is equal to 3 over 5. Next up, we can see that there's no reflections because there's no negative value here. Now, the last really important piece of information we need to know is the period. And that has the formula 2 pi on n to work out what the period is, where we look for n as the value that's multiplying the x inside the bracket. So in this case, it's pi divided by 12 is the value of n. Therefore, our period is 2 pi divided by pi over 12. And we can evaluate this by going 2 pi over 1 multiplied by the reciprocal, which is 12 over pi. And the pi's will cancel, leaving 24 as the period of this graph. And that's quite convenient because we want to sketch it between 0 and 24, which turns out to be exactly one period of the graph. So as there's no reflections, our sine graph will just look something like this. And now our job is to label all of the maximum, minimums, and axillary intercepts. So this value here is going to be 0, 0. So x is 0, y is 0. And then this value here is going to be 24, 0. So that's one period's worth of the graph. And these are both coloured in dots because both of these brackets are square, which means it's included. Now, because our circular functions are symmetric, it means our x value here is going to be halfway between the two values we have. So it's going to be 12, 0 as the third and final x-intercept. And then the maximum and minimums are going to occur halfway between the intercepts. So this value here is going to be halfway between 0 and 12, which is 6. And it's going to go the maximum distance away from the mean value of the function, which we know is the amplitude. So it's going to have a y value of 3 over 5. Similarly, for this minimum, it's halfway between 12 and 24, which is 18. But this time it will go in the negative direction, the value of the amplitude, which is negative 3 over 5. So that's the full sketch. That's everything we need to do. And now on this slide, we've just got a computer to generate a bit of a nicer graph for us so we can get a bit of a better feel than the sketch I did. And it has all the same key features as we found before. And just keep in mind that this 0.6 is equal to the 3 divided by 5 we had on the previous slide. So they're both equally correct.